Okay. Hello, everybody. Now I shall continue discussing with you the last virtual instrument, which I tried to explain to you, but I didn't complete my discussion. The block diagram, if you remember, as shown here, consists of a while loop with an vision acquisition virtual instrument and vision assistant also tool. In the previous lecture, you remember I told you that there is a path through which we decide the position of the image which we are acquiring. And I showed you that if I double click this icon and open the vision assistant, you will see, okay, now it will, yes, you will see this path to the file. And if I go further and finish with this and run the program, we will have these two images. One of them is a color one, and the other one is a grayscale one. And why this is happening, you know, this is because, as you see here, we have the vision assistant, and internally, within the vision assistant, I converted the image, this image, converted it to a grayscale one, this one, which is at the input, which is the output of the vision acquisition, and it is fed, as you see, the output here comes from the output of the vision assistant, and the input of the vision assistant I have taken directly from the path, directly, as you see, to the vision assistant. When it is manipulated there and converted, we will see this second image, which is already processed. So what does this mean? Indeed, if we go back, again, I will stop the program. It takes some time because the time constant of the timer was 10 seconds. Now it will stop. Okay, so when I go back to the block diagram and open the vision acquisition, we will find something interesting. The system, here we are in this page, here is the file path. I go back and I see this page, you know this page, I have discussed it with you. I go back again, and now I am at the root of the system. Here you see that the camera is not working. I did not use the camera to acquire an image. I used the simulation or simulated acquisition and clicked folder of images. So when I click folder of images, This means that I have to go to an image through its path file and then continue working as traditional, and there is nothing to add to this. So I have clicked the folder of images, then I go next. I selected acquisition for one time, single acquisition only, because the image there is stationary in the file. Next, now this block appears empty. I fill it with the address I want. Now look, now if I click it, I can go anywhere in the system. Let me go to the desktop, for example, to Jupyter Programs, Python folders, tutorial 1. Here I find, as usual, many different images which I have downloaded before from the internet. So if I want this image, I put this image. This is another image now. Okay, next. And I have finished. When I run the program, now this new image will be displayed. Is there something wrong? Oh, yes. Let me go back. I stop it. It takes time, as I told you, to stop. I can really shorten that time, but intentionally I put it a little bit long to make you feel what the image is. So I go to the block diagram again, and Vision Assistant it is initializing now. Here is the image. I'll change the image. Let me take, for example, this fellow, human. Now, next, and finish. It seems to me it should be okay. When I run the program now, I have two images. One of them is the originally displayed one, and the other one which is manipulated by the Vision Assistant and converted from color to grayscale. Okay, now I shall go back again to the block diagram and show you also something interesting. So I open it again. The Vision Assistant, I'll open it again. I go back, again back, and now look at the root here. You find that I have clicked folder of images, which means I have to go to any folder and pick from there the image I want to display. But if I want, I can also display audio visual interleave images. Audio visual images. Let me show you. If then I press it here, now I go to next. I want now, because it is video, I want to continuous motion. So I click here. Okay. Next. And now I need to go to a file where AVI images are saved. Audio, visual, interleave images are saved. This is not AVI file. So I go to the desktop, for example, LabVIEW image processing. These files, which are here, I have stored and worked with before, are AVI files. I double click here, and now I have this Ali AVI file. I go to next and finish. Now it is configured. Now, if I go back and run the program, sure, I shall see another image here. Okay, and it will be moving. This is the other one here, the colored one. It must be moving. I have maybe, it is moving, but because the time interval which I put there is 10 seconds, so it takes 10 seconds to, as you see, to step. So maybe and it's worthy to go back and to shorten that time. I stop the program, or from here quickly, I go back to the block diagram. Here it is 10,000 milliseconds. I make it, let us say, 100, 200 milliseconds, for example, which is 2 seconds. No, 200 milliseconds. Yes, which is dot 2. So that's okay. We go back, and now we run the program. We will feel it has disappeared. Why? It is very quick. It is normal. As you see now, this is read from the file which I have read, which I have written before. So as you see, the images are displayed directly from AVI file. Okay, now let me also stop this program and go back again to the block diagram here. When I configure the vision acquisition another time, I will configure it to show you that we can display a folder which has several images there to be displayed one after another. So here I try to go to one file I have written before, hopefully to remember where it is. I go to the desktop to LabVIEW image processing, and I think that I have saved there one day. I have downloaded a file with a folder with 3 or 4 images together. Okay, yes. It seems video processing using LabVIEW. Here is that folder. But he is telling me no images, no items found. Okay, maybe, and here it doesn't respond. Okay, let me go back again. Try to, if possible, to open it. Save. Okay. Cancel. Last trial here. This is the old one. So go there. Maybe one click is sufficient. I am sorry for you. It doesn't appear. Anyhow, I tried one day. It worked well. There were 3 images there. And when you display, maybe it was, no. Okay. So I think we finish with this up to now, with this subject. And then we move now to a new paragraph in our work related to color technology and color modifications. So, as usual, I shall try to illustrate with you the material through examples. I have collected a lot of examples here, but I will select for you only the most interesting. Also, to save your time. So we begin with this first program, acquire with CAM0 and resolve image to its RGB. So what we need to do here, we are going to acquire an image, and then we shall resolve it to its components, to its 3 planes, the red plane, green plane, and the blue one. So as you see here, we have, as usual, this is the cam, the camera itself. This is the grab function, which is here. This is the create memory location for the image which is going to be displayed. Okay. We know these things. Now the image is here. Where the pointer here image out. This is the image out, and this is the image which is going to be displayed. In the block diagram, in the front panel, it is this image here, the colored one. Now, the target is to resolve it to its 3 components. What we have to do? The most important, if we want to get at the output 3 images with unsigned 8-bit for each, so we need here at the input of this function here from the left side to locate memory areas for each of the 3 planes, the 3 grayscale planes. This function here, which resolves the input here is this one. As you see, this is the output image, which comes from the camera. Here it is fed to the extract color planes function. Extract color planes. It is at first here, at the top. This is one of them, the inputs. And the other three inputs, one of them is going to be at the output here, and its reference or memory is this one here, red plane. Through the create function, I have located an area for this grayscale image to be displayed at the output. I called it red. The same thing, I have also located image area for the green component, and the third one here, which is for the blue. Remember that the outputs here should be grayscale, and the depth of the pixel value is 8 and not 24. So the allocated area here, which is done through the IMAQ create, is at the beginning U32, but here it will be U8. I don't know why this input is connected to the blue from here. It seems to me something wrong with it. I will cancel it, and it should be connected from here. Now it is okay. Here we are acquiring the image by using the grab function. So in order to limit the acquired images, I do not need to save many images here. There is no delay time included in this while loop. So it runs with high rate of iterations equal about 1 millisecond only. So I included here this small code where the iteration number must be, if the iteration number higher or equal to 2, then the loop will stop, which means that I am allowed to take images from 0 to 2. I begins from 0. So it is 0, 1, 2. We will have about 3 images, which I wanted to capture here. So if we go back and run the program now, we go to the front panel and acquire the image. You will see invalid image type. Where it is invalid, it should be here 8 instead of 32. I go to the front panel. Here, it is okay, it is normal. It is not 32 U8, so there is no problem with it. It is grayscale U8. Let us go back and see where the mode here is RGB. Here really I didn't include the open function. Maybe it was missed accidentally. So, sorry, I go there And go to Vision Utilities, external display. No, I need an IMAQ DX. I open it. Here is the open. And now I connect the session or the camera to the open, and this is not required. And I connect this here. This also shall be reconnected correctly here, and from here to the input there. And now I think it will be okay. So again, when we try, hopefully that everything is okay. When we go to the front panel and acquire an image, no, invalid image type. I did not here decide what image to do. IMAQ extract color plane. It is okay. Here is also RGB. I told there is no problem with it. Here is the image. This is the source. That's it. It is okay. I do not see any problem with it. Except this one again. Let me finish with it and go back. Yes. Block diagram. Create constant. Here it is U8. And this U8 shall be connected with the three inputs. Okay. Now, if you go to the front panel again and try it, why it is so? Here is okay, Grace. Okay. Again, we are acquiring here the image, which is the original image, which should be 32-bit and not. I think everything is okay now. We go back to the front panel and try it. What is there? Something wrong. Time out. Okay, this is not related to the program. Okay, let me fix it here. Go to dialog and with the simpler handler, close it. Okay, and now again, go to the block diagram. Not yet. There is something wrong with it. What is the problem? Maybe the problem is again with the video. Let me stop the video and go back. I think this is the problem with Zoom, related to Zoom rather than to the program. Again, this is the last trial, otherwise I will. Yes, it is. It is okay now. So as you see, this is the image. And these are the three components of the image. One of them is for the red, and this is one. Let me raise it up. This is image 2, 3, and 4. Let us compare between them. If we compare between them, we find here, you remember the standard resolution of the image 640 by 480. This is normal. But we have 32-bit because it is colored. Red, green, blue image. If we look down at each of the three grayscale images, we find here that it is the same size, the same resolution, but here it is 8-bit image, 8-bit image, 8-bit image, which means that these are grayscale images. So when we extract with the function, the images here, extract color planes, here at the output we get 3 images. Each word or each pixel consists of 8 bits. But as you see, the input image, of course, which is colored, consists of 32 bits, which we have seen there, here, 32 bits. So this is some way of converting the color image to a grayscale one. I think there is no more information to tell you about this VI. I finish with it and then we move to another program. Okay, so I would like to save it with the changes I did. File, save, file, exit. Okay, so we go to the second program. Convert from color image to color image. The previous one was converted from color image to grayscale by extracting 3 images. 3 images of the 3 planes which compose the red image. Now we are going to resolve the color image and then again to combine it. So as I guess this is one of them is the input, yes. And this is the output, which should be the same, because after we resolve or extract the 3 grayscale images, we again create them. How we do that? Which function is there? There is another function called replace color plane. IMAQ replace color plane. This replace color plane works with an input equal to the 3 8-bit images, grayscale type 1, 2, 3. 1 for the red. Here, the red one. Yeah, this is the red one. The second is the green one. This is the green. And this is from down is the blue. Its position is there, the blue. If you want to see exactly how it is in the reference, okay, you go to the help, and there you will see exactly that here is the blue one, the blue or Luma, and this input is for the green, and the upper one is for the red. The first one is the source image, and this is the destination, which means the area located for the image which is going to be displayed. I did not connect it. I connected only the destination one. So here at the input, as you see, we have, first of all, an image which is going to be acquired. I am going to acquire an image, and I have designated for it RGB unsigned 32-bit type image. And here I have read the image from this path of the colored eggs, and this is the output which displays the first image. Now this image is fed here as the input in order to extract the three components at the output, the red, the green, and the blue. But to have them as the output, I need to allocate for them, I told you, 3 places in the memory with type unsigned 8-bit type images. So this is one for the grayscale for the red, and one grayscale for the green, and one grayscale for the blue. What is this? This is also a memory assigned for the image which I am going to display here. If you look here, you will find destination, image destination. So this is the image destination, or the destination where we will put this image there, which is at the output. Okay, so again, we have two major functions. One of them we have already known. It extracts 3 planes of the colored image. In other words, it gives an output 3 grayscale images. We have done this in the previous example. But now these 3 components are fed to the replace color plane. The input, the upper one, is just to locate a memory for the output. Now this function creates from the 3 grayscale images a colored image as the output here. So this image here is the output, and this image here, sorry, why it doesn't show? And this image here is this one here at the input. Now, why this is image and this is image 2? When I fix them on the block diagram, I drawn this before I have drawn this. That's it. Now, back to the block diagram. The acquired image now, the created newly image, is saved by using the write function to a file, and this path of this file shown here. 3 apples. It is called 3 apples because before I saved this two image, with this image, I have read one of them and saved the other one. I use 3 images, 3 apples. Okay, I can go back, and just to be consistent with myself, I'll go back and find these 3 apples and put them there instead. Here they are, and put them there. Now, if I run the program, Okay, I have done something wrong there. See users Dell pictures 3. This is the destination where I saved them. I have clicked here. I should go there and double click here. And now I shall have the apples displayed. So when I display now, I shall have the apples displayed here and recreated by using this replace color plane function. This is interesting and used very often in work. So I hope that this program now has shown you how we can do it. Okay, with this program, we finish, and let me also discuss with you another program. I think I have time for it. Example number 3, it is called color planes also. Today we have many apples, as you see. So if we go to the block diagram to understand what is there, it seems that also this is something interesting. So what do we have? Here we have the read function. I can fix it for you. Not IMAQ read file, and we need to read this file. File path here is shown here, the apples themselves. So now we are going to read this file, and we have created a memory for it, for the image which is going to be read. This is the read image, which is acquired at the same beginning. So this is our image. Now we have acquired an image as usually we do. What is there? Here we have IMAQ extract color planes. So we are supposed to have at the output 3 grayscale images as we did before. And in order to get them, we need to allocate for each of them a memory space. One is, let me show you better how it is. This is not good. So one of them for the blue, this is the blue, one of them for the green, and one of them for the red. Here is one for the red, and one for the green, and one for the blue. And in addition to this, we need to give the original input, the source image source, SRC. So this is normal, and we know that it works and should work in this manner as we did before. So what is new here? The new thing here is the use of IMAQ cast image. What is this? This is a very, very useful function used in IMAQ in order to get the required image type. Let me show it to you first, and then we will continue our discussion. When we go to Vision Utilities, I think in the management here you find IMAQ cast image 2. This function really, let me put it here and show you what it is why it is important and how it works. So this function here is very widely used in order to decide the type of the image which you get as the output. For unforeseen reasons, sometimes you did not get the image you want. There is something wrong with the program or some conflict between different functions. So using this function, by deciding image type at the input, you get the image which you want at the output. You have an image source previously. You have allocated for it a place. And now the new thing is you add here this input, which determines the output you want. So here at the input of the image type, you need to include the type you want. Is it, for example, an image with U8 or I16 or unsigned 16 or unsigned 32 bits? Depends. Here you can decide that, and then you can overcome any conflicts or problems with the output image. So this function converts the current image type to the image type specified by image type, specified by this input, which is called image type. This is which I have done here to show you. So, as you see, this is the image which we have, the source image. Image is us. Here is the destination. This is a memory allocated for the image will be at the output. Suppose at the output I need an image which will be grayscale unsigned 16. So here this input, which was called type, no, not lookup, it is called, okay, I'll show you again because it's important for you to remember, which is called image, no, image type, which is called image type. It is put here now, no problem. So this is the image type input. Here I decided what really I do. Only what I do, I can clean it. Sorry. And I finish with it. Now created newly. Here, create constant. No. I have created the table there. Or maybe it is down. Here it is down. Image type. So I right-click it, create constant, and now I have the options which will decide the type at the output. Suppose I want the output not U8, I want to have an image, as you see, U16, unsigned 16-bit. Here it is. Now here we shall have unsigned 16-bit image. So when we run the program, sorry, oh, there is something wrong as, yeah, okay, because of this one here, I clean it. Now when I go back to the front panel and run the program with these apples, I get the following. These three images, as you see here, 8-bit image, 8-bit image, 8-bit image. This is the blue, this is the green, and this is the red in grayscale. This one here is the grayscale unsigned 16-bit image. This is different image than those. This is the target of this program. So to show you that how we can use the IMAQ cast function, and to show you also how really we can again resolve the image to its three components and compare these three components with the unsigned 16-bit image. Okay, I think today is enough. Next lecture, we continue discussing color image modifications and exercises about that. Okay, wishing you the best and hoping for you a happy day and goodbye.